Ever wondered how the trig functions get their values? Well, in this video we'll define the trig functions and use them to find unknown side lengths and angles. We name the sides of the triangle by their positions relative to the angles in the triangle. The hypotenuse is opposite the right angle, the opposite is opposite the given angle, and the side that's next to the angle is called the adjacent. And it doesn't matter what the orientation of the triangle is, it's all relative to that given angle. Starting with a circle of radius 1, which we call the unit circle, we'll rotate a point P on the circumference there on the positive x-axis through some known angle, which we'll label as theta. We now have a right angled triangle with a hypotenuse of 1. And we define the cosine of the angle as the x-coordinate, which is the length of the adjacent side. And we define the sine of the angle as the y-coordinate, which is the length of the opposite side. Let's move our angle into the second quadrant. So we have an angle here that is theta less than 180. The sine of that angle is the y value. It's the same as sine of theta. Whereas the cosine is the x value is negative there. So we get the cosine of that angle is negative cosine theta. Moving into the third quadrant, we'll have an angle that is theta bigger than 180. The sine of that angle, the y value, is negative. So we'll get the sine of 180 plus theta is negative sine theta. And the cosine of that angle is negative as well. And so we'll get the cosine of the angle is negative cosine theta. Moving into the fourth quadrant, we have an angle of 360 less theta. The sine of that angle is negative. And so we get the relationship where the sine of 360 minus theta is negative sine theta. And the cosine of that angle is positive, so those cosines are equal. So far we've only considered a hypotenuse of 1. When we have a triangle that's twice as big, so that the hypotenuse is now 2, then the adjacent side is twice as big, so that makes it 2 cosine theta, and the opposite side is twice as big, so that's 2 sine theta. So let's extend this to a triangle that's h times as big. That means the adjacent side is h times cosine theta, h times as big, and the opposite side is h sine theta. Now we don't really need that unit circle to work out those two sides, nor do we need the small triangle. We can just work with this big triangle here, and we'll have the adjacent side is equal to h times the cosine of theta, and the opposite side is the hypotenuse times the sine of theta. Let's have a look at the definition of tan now. We can define tan along the tangent line. The tangent is defined as the length along that tangent line when the angle is theta as shown. Note that this time the adjacent side is 1, not the hypotenuse. Making the triangle a times as big, where a is the length of the adjacent side, means that the whole triangle is a times as big, so the opposite will be a tan theta. Once again, we don't need the unit circle to work this out, nor do we need the smaller triangle. We can just work with the sides of this larger triangle. So to find the side length of the opposite there, we multiply the adjacent times the tan of the angle. Let's have a look at the ratio definition of the trig functions. So if we have a right angled triangle like that, we can define the sine of the angle as the opposite over the hypotenuse, the ratio of the opposite over the hypotenuse. Cosine is defined as the adjacent over the hypotenuse, whilst tangent is defined as the opposite over the adjacent. Using the definitions of sine and cosines shown, and the definition of tan as opposite over adjacent, we can define tan in terms of sine and cosine. We do this by dividing both the numerator and the denominator by the hypotenuse, and then we can see that the opposite over the hypotenuse, the numerator there, is the same as sine of the angle, and the denominator is the cosine of the angle. So we can write tan theta as sine over cosine. We have what's known as the Pythagorean identity. Looking at that in the unit circle, we know that the hypotenuse is 1, and so if we square both the side lengths of that right angle triangle and add them up, so we have sine squared plus cosine squared will give us 1 squared. We can work out what the sine, cosine and tangent of 30 and 60 degrees are exactly. To do this, we'll draw an equilateral triangle of side length 2 so that the angles there are each 60 degrees. Then we'll divide that triangle into 2 so that we have a 30-60 right angle triangle. By Pythagoras' theorem, the altitude of that triangle is root 3. And so we can work out what the sine of 60 degrees is. That is the opposite over the hypotenuse, root 3 over 2. The cosine is the adjacent over the hypotenuse, 1 over 2. And the tan is the opposite over the adjacent. And we can do a similar thing for 30 degrees. The sine being the opposite over the hypotenuse, so it's 1 over 2. Cosine is root 3 over 2. And the tan is 1 over root 3. You'll notice that the sine of 30 degrees equals the cosine of 60 degrees, and likewise the sine of 60 degrees is equal to the cosine of 30 degrees. We can also work out what sine, cosine and tangent of 45 degrees are exactly. To do this, we'll construct an isosceles triangle, and the side lengths will label as 1. Note that there are 2 angles of 45 degrees there as well as the right angle. Now by Pythagoras' theorem we can work out that the hypotenuse is root 2, from which we can say that the sine of 45 degrees, and we can use either of those two 45 degrees there, the sine is 1 over root 2, the cosine is 1 over root 2, and the tangent is 1 over 1. Let's have a look at some examples now. We have a right triangle and we want to find the unknown side marked x. We know the angle and we know the hypotenuse. So the unknown side x is the opposite, so we can write down our equation there for opposite using the hypotenuse. That is, opposite is hypotenuse times the sine of the angle. We can substitute the values in and then solve for the unknown. So our opposite is x, our hypotenuse is 10 and the angle is 30 degrees, so we need to work out what 10 sine 30 degrees is. We can use our exact values. For sine of 30 degrees is 1/2, or if we don't remember them we can use our calculator. So our final answer is x equals 5. Another example where we are trying to find the unknown side length x. This time we'll observe that we have the hypotenuse as the unknown side and the adjacent is the given side. So once again we have to work out what trig function we have to use. And the equation that we need is adjacent equals hypotenuse times the cosine of the angle. Substitute the values in that we know. The adjacent is 1.5 meters. The hypotenuse is unknown, that's marked as x, and the angle is 25 degrees. Solving for x, we need to divide both sides by cosine of 25 degrees. Like that, and then we can calculate that on our calculator and we get 1.66 meters. In this example we have a 5 meter ladder that leans up against a wall and reaches 3 meters up the wall. We're asked for the angle between the ladder and the ground. Now the first thing we notice that there is no diagram here, so we have to draw our own. So we'll put all the information into a diagram. We have a 5-meter ladder and it reaches up the wall 3 meters. We have a right angle triangle, and now we need to identify the sides by their names. So we have the hypotenuse and the side that's opposite the angle. We then decide which trig function to use here, and of course sine uses opposite and hypotenuse. We'll use this form of it because we are trying to find the angle. So now we substitute the values that we know. The opposite is 3, the hypotenuse is 5, so we put those values in. And note here that we're not finding the sine of 3/5, we're finding the sine of the angle as 3/5. So we have to find the angle. So we need to get the inverse function of sine. That's written as sine to the -1 using that notation. So we want inverse sine of 0.6, which we'll do on our calculator to get 36.9 degrees. When we're finished, we'll write our answer in words. The angles of elevation and depression are always taken from the horizontal. The angle of elevation means that we're going up, and the angle of depression means we're going down from the horizontal. A pilot observes that the angle of depression to an airport is 40 degrees. He is flying at 7,500 meters. What is the ground distance from the plane to the airport? No diagram supplied with this question, so we have to provide one ourselves. So there's all the information. The angle of depression is 40 degrees. The altitude is 7,500 meters, and the ground distance is what we're trying to find. We'll label that as X. We'll note that the angle of depression there is not in the triangle, so we can find one within the triangle, observing that we have a right angle there, so we subtract the 40 from 90 to get our 50 degrees in the triangle. Now we can use that triangle and find the unknown side length X, which is the opposite, and we have got the adjacent. So with those two, which trig function do we use? That's right, we'll use tan. So we've got the opposite side is adjacent times tan. Put the values in that we have. That's the 7,500 and the 50 degrees, and then calculate that out on our calculator to get our answer, which we'll write in words as well. So we've seen that we can use trigonometry to work out unknown side lengths and angles. We use cosine when we're dealing with the adjacent and the hypotenuse. We use sine when we're dealing with opposite and hypotenuse, and we will use tan when we're dealing with opposite and adjacent.